In the concept bite, after lesson 6.1, you solved one-variable linear equations using graphs and a graphing calculator. You learned that a system of linear equations has 0, 1, or infinitely many solutions, and that the intersection of the graphs of the equations is the solution. Solving systems by graphing is a useful method when you're not sure how to solve the systems algebraically. Consider the system of equations. Y equals 2 to the x power, and y equals 0.5x plus 2. The system is graphed here. Note, because one of the equations in the system is not linear, you can have more than one solution. The x value, where the functions intersect, is a solution. In the next example, you will write each side of the equation as a function and graph the functions. The x value, where the functions intersect, is a solution. Problem 5. Solving one-variable equations. What is the solution or solutions of 2 to the x power equals 0.5x plus 2? Step 1. Write each side of the equation as a function equation. This means writing f of x equals 2 to the x power, and g of x, a separate function, equals 0.5x plus 2. Step 2. Graph the equations using a graphing calculator. So I'll show you both the graphing calculator and Desmos graphing utility to complete this problem. So in graphing, we'll use y1 for one of our functions, in this case f of x, and y2 for our other function, in this case g of x. So for y1, we'll have 2 raised to the x power, and for y2, we'll have 0.5x plus 2. So there are 2 functions. On a graphing calculator, we can use the calc feature. To do that, we'll push second and the trace button, which when we push second becomes the calc button. And we want to find the intersect. So we'll arrow down to, in this case, option number 5, the intersect. And it asks first curve. And if you look really closely, there's a flashing cursor on one of our 2 functions. What we'll do is we'll arrow to the left in order to move that cursor so that it's to the left of our first point of intersection. Because you can see we have a point of intersection, it looks like here on our graph, and another point of intersection here. So those will be 2 places where the functions are equivalent. So first curve, we push enter to identify that as our first curve, enter again to represent our second curve, and then the calculator is prompting for a guess. And so we need to move our cursor close to the intersection just to help the calculator or help speed it along in its algorithm as it calculates. All right, so the intersection, x equals negative 3.8625, and y is really close to 0, 0.0687, and so on. So there's one of our intersections. And you can see if we look at step 3, the example problem is also identified about negative 3.86 as being one of our solutions. To find the second, we will use calculate again, intersect again, but this time for our first curve, we'll move closer to the other intersection. Second curve, the cursor jumps to our second function, and then for our guess, we move really close to the actual intersection, and we find that our second intersection is at x equals 1.44 approximately. So that's the value we're looking for, and we can see in our step 3 that solution is identified as well, 1.45. To complete the same steps on Desmos, we'll graph our two functions. First, y equals 2 raised to the x power. And second, y equals 0.5 x plus 2. All right, the graph looks similar, arguably much more presentable and nicer. And now rather than using some calculate feature we have to hunt down in our menu, we can much more intuitively and visually click to identify these points. 1.445, that was the second one we calculated a moment ago using the graphing calculator. And the other point of intersection, an x value of negative 3.86. Arguably, Desmos being the much more efficient, much more attractive, and much easier to use solution. Your turn. Part A. What is the solution or solutions of the equation 0.3 raised to the x equals 5? Part B. What is the solution of the equation 1.25 raised to the x equals negative 2x? And part C. What is the solution of the equation negative, the quantity 2 raised to the x power, equals 3/4 x minus 4?